In the early 19th century, experiments seemed to confirm this theory. Atoms do really exist. They were thought of as round, solid balls that couldn't be divided into smaller parts. Almost 100 years later, at the end of the 19th century, a new discovery was made. Atoms can emit even smaller particles, electrons. So the atoms can't be the smallest component in all matter. They are not indivisible. Since the 1930s, we know that atoms consist of three types of particle. In the middle of the atom, in the atomic nucleus, we find protons and neutrons. And around the nucleus, there are electrons. At first, it was thought that the electrons orbited around the nucleus like planets around the sun. Now we know it's a bit more complicated than that. Instead of orbits at fixed distances, there's more like a cloud of electrons around the nucleus. You could say that the electrons are everywhere in this electron cloud at the same time. The electron cloud is huge compared to the nucleus, tens of thousands of times larger. If we were to draw an image of an atom to scale, the nucleus would be no more than a tiny dot. This way of drawing an atom isn't very clear, so most of the time we depict the atom with a magnified nucleus and the electrons in orbits around it. It's a useful model to show what the atom is made of without going into too much detail. In a chemical reaction, it's possible for an atom to lose some of its electrons, or pick up more electrons, or share electrons with each other. The atomic nucleus is more stable. It's not affected by chemical reactions. Now that we're down to protons, neutrons, and electrons, does that mean that we're done? Are these particles the smallest units of matter? Or can they be divided into even smaller parts? As far as we know, an electron can't be broken down into smaller pieces. It is a fundamental particle, or elementary particle. How about neutrons and protons? They consist of smaller particles called quarks. 3 quarks are needed to build 1 proton or 1 neutron. One special thing with quarks is that you can never isolate a single quark. They always come 2 by 2 or 3 by 3. We don't think they are made of smaller...
What is it made of? Helium gas is made up of tiny particles, helium atoms. Atoms are building blocks that make up the world. They make up gases, liquids, and solids, all the matter in the world. Atoms themselves are made up of different parts too. Atoms are often pictured as models that resemble tiny solar systems, with a nucleus at the center and electrons orbiting around it. Let's take a closer look at the nucleus first. The nucleus is made up of 2 different types of particles, protons and neutrons. Protons and neutrons have a similar mass, but protons have a positive electric charge, while neutrons have no charge at all. The number of protons determines which element an atom is. For example, all helium atoms have 2 protons in their nucleus. That's how we know they are helium atoms. Atoms with the same number of protons in the nucleus make up the same element. There can be anywhere from 1 to 118 protons in a nucleus, so there are 118 different elements. The number of neutrons in the nucleus of atoms of an element can vary. Take these 2 atoms with 2 protons. Both are helium atoms, but one has 2 neutrons, while the other has 1 neutron. These 2 atoms are 2 different variants of helium. Variants of the same element that differ by the number of neutrons are known as isotopes. Most elements have several isotopes. So, protons and neutrons are particles that make up the nucleus of an atom. They are the heaviest parts of the atom, and their combined mass is nearly all the mass of the atom. What about the electrons? In an atom, there are always as many electrons surrounding the nucleus as there are protons inside the nucleus. Each electron has a negative electric charge. The positively charged protons and negatively charged electrons balance each other out. This makes the overall charge of the atom neutral. In our model, it looks like the electrons are just a bit smaller than the protons and neutrons. But in reality, electrons are much smaller than the particles inside the nucleus. Their mass is so small it hardly even counts in the mass of the atom. What's more, electrons do not follow neat orbits like our model suggests. Instead, they fly in all directions, forming an electron cloud. And lastly, Electrons are much further away from the nucleus than it appears in the model. Picture the nucleus as a tiny lentil placed at the center point of a football stadium. The electrons whizzing around it wouldn't even be inside the stadium. Most of the atom is just empty space. Electrons, especially those in the outermost layers, allow different atoms to react with each other. This way, individual atoms can combine with others to form molecules. So now we know all matter in the world is made up of tiny atoms. Atoms themselves are made up of even tinier particles. Positively charged protons, negatively charged electrons, and neutrons that have no charge. Protons and neutrons are clustered in the nucleus at the center of the atom. The number of protons in the nucleus determines what element the atom is. And the number of neutrons tells us what variant of an element, what isotope, the atom is.